Hey, welcome to the video. Today is the fourth video in a series of videos dealing with retrieving your Wi-Fi passwords in a Linux environment. Today is the last one of the Linux environment series. There is a next video talking about how to do this in Windows, but today we'll talk about how to create a little output table in your command line interface showing you the retrieved passwords for each of your Wi-Fi networks. Check it out.
At the end of the previous video, we ended up with a list that has all the fields related to every Wi-Fi network that we've been on. So this is the name, it is a Wi-Fi network, a bunch of other pieces of information, and importantly, the password that we want to know about. So now let's stick that in a representable table in the command line. So I have the function output to terminal. The inputs are fields, which is the field list at the top, which holds all the field names or the column names. They're going to be column names in our table. And it holds the output list, which is a list of lists. Okay, it's a list where each of the element is another list that contains all the meta files related to this particular network. So of course, this will be the output from the previous function we talked about. Okay, so the number of items in the output list is a number of network files found. So basically for every network file, there is a list in the output list, and each of those lists has the number of columns defined in the fields list. Okay. So the first thing we will need to do is we will need to find the maximum width needed for each column. So how are we going to do that? Well, first we will look through the fields list, which has all the column headers. And then we will look through the output lists and look for every word, if you like, that needs to be put in that column. So for example, if we're looking at the first column, that will be ID, okay, ID equals. Now we're going to get rid of this equals, but leave that, forget that for a second. We'll look at ID equals, and that is clearly not a very long word. If you look at the first network we came across, so output lists 0, that's the first network we came across, and within that it will be the first element of that list, because the first element of that list is ID. That is this word here, which is clearly longer. So in this case, we want the column width to be at least as long as this is, so it can take the entire word. Okay. So as an example, we could come up with a list that has the values 3, 8, and 8, where 3 is the length of ID equals, and 8 is the length of this network name, and 8 is also the length of the second network name. Now we had 4, I'm only showing 2 here. But then we take the maximum, of course, of each of those, and that will be the width of our column. Okay, so we store that in a list, and that list then holds the width required for column 1 and the width required for column 2, and so on. Okay, so there's a long way and there's a short way. The short way is a list comprehension, but I'll take you through the long way first. Okay, so we'll have a list called maximum lengths, okay, which is what this list will be here. So I'm going to look for each ID in the range that is defined by the length of the fields list. Now the fields list, remember, is the list that holds all the column headers. So the length of that is the number of columns that they're going to need. So for each ID in basically every column, I'm going to store the length of each element of that index and then take the maximum as the column width. Okay. So I'm going to create a temporary list for each index. So for each column, basically, okay. Firstly, I'm going to store the length of the column header, and that sits in the fields list. Okay, so in my temporary list, the first element in there is the length of the column header. So in my case, that's 3, because the length of my column header is 3. Then I'm going to go through all the elements in my output list. So that is every Wi-Fi network file, basically, right? And in each of those lists, I'm going to look at the index of this particular loop, and then pick up how long the element is in that list. Okay, so that's effectively what we're doing here. The index is 0. that will take me to the first element of my fields list. The length of that is 3. So I'm going to store 3 in here. Then I'm going to go to my output list, and the first element there is related to this network. It has all the meta fields of this network. I know that I'm looking at ID 0, so I'm going to look at the ID 0 in that list, which holds the ID of that network. Okay, then from that ID, I'm going to pick up the length. Then I'm going to move on to the next row in the output list and do the same thing for here. The next row in my, or the next element in my output list, which will be the next row in my table, that has to do with the second network I came across. That holds all the metadata for my second network, and at index 0, it holds the network name. So there's this one. I then calculate the length, which is 8. I'm going to stick that in here. Okay, and we'll do that for the next 2 files as well, or for the next 2 list elements in output list. So that's what this for row and output list does. It appends the length of the index we're talking about right now. So how does that translate into code? Well, I'm going to run a for loop over my output list, and I'm going to call this row because I'm working on a table and I want every network to be represented as a separate row. Okay, so I'm just going to call it row because each element in this list represents the metadata for one of my network files. Now each element in this output list is a list, okay, and the first index, or index 0 of that list, will be the network name. Now I want to exclude anything from my table if the first element of the row is none. Okay, if there's nothing in there, I don't want to represent that. So this is just what this if statement does. So it only appends the information to my temporary list if row 0 isn't false. Okay, and what's it appending? It's appending, well, from the row, which is my table row or my element in the output list. It looks at the index in question and it takes the length of that. So in other words, that's what this piece is doing. Okay, that, and then it appends the 8 and 8. So that gives me a temporary list that holds for each column, or for the column in question, which is represented by this ID, it holds the width of each row in there. So it starts with the width of the header row, and then the width of the first row, and the width of the second row for that particular column. So what I now want to do is, well, how wide does my column need to be? Well, it needs to be the maximum of this list. If it's the maximum of the list, it will be able to hold every word in there. So max lengths, which is my list, I'm going to append, what am I going to append? Well, I'm going to append the maximum within this list. Now for that, I apply a list comprehension. Now this is a very simple list comprehension. I'm not applying any functionality to it. I'm just saying for every X in list TMP, give me the maximum of that list. Now to be perfectly honest with you, in this case, you don't need a list comprehension. The reason this is a list comprehension because if you want to be very precise, you should convert that to an integer, because we will need integers. But because these are all integers, you actually don't need that. So you could just, in this case, take the maximum of that list, and then you don't need the list. That will also still work. So that is a long way of doing things. Okay, you can actually stick all that in one big list comprehension. So the list comprehension is here. That's quite a long one. So let's talk through this list comprehension, because it's a nested list comprehension. Effectively, you start from this and you just stick it all into one list comprehension. And there's actually 2 ways of doing it. And to make it easier, let's just start with the first one here, because that uses the same logic as what we did above. So that is effectively taking just all this code and sticking it into one line of code. Okay, so for IDX in that range of length fields. There you go. That's at the end. Okay. Now, what do we want to do for that? Well, we want to have a maximum length. Okay. And where does that maximum come from? That's a maximum of list temp. So we're going to create a list comprehension for list temp and then stick that in this max function applied to list temp. This max function here is this one. And then list temp is being replaced by another list, which is this one here. Now you see a second max here and you go, well, there's no second max up here. That's right. So why is that? Because the first element in here is the length of the column header. The rest of the elements will be the lengths of the rows. So effectively it has to be the maximum of either the column header or the rows. So that's what I'm doing in here. I'm saying, well, I'm taking the maximum of the column header here and the rows in here. Okay. So how does this work? IDX index is defined by this loop here. Okay, so this is not going to change. And then here I take the length of the row element with this index. Now, of course, the rows, there's more than one. So that is the looping that's happening here. That happens for each row in the output list. If row 0 is true, right? So that if row 0 is true, here I was appending this length to the temporary list. So that is effectively what this is doing here. So that gives me a list where every element shows me the maximum length or width required for that column based on the header and based on each of the rows. Okay, that's why that is a list comprehension. And then I take the maximum of that list, which is what we were doing here. Okay, so that's one way of doing the list comprehension. The other way of doing that is by avoiding the range len fields here, because effectively you're looking at how many elements there are in fields and then you create a range from 0 to that number. The other way of doing that is by just using the index of the elements in fields. Okay, so this is what we're doing here. So the logic is the same, but what we are changing is, instead of saying for the index, and there was just saying for every element in the fields list, so for every column header, we're then going to do effectively the same thing. Instead of saying we take the length of the element with index IDX in fields, well, we're just calling that element because that's exactly what that is. So we take the length of this element, which is an element in fields, so that's a column header, and then we take for each row, for every row in the output list, if row 0, we then take the length of the element in the row which has that same index. So which index? Well, the index of the element we are in. An element is from fields, as you can see here. Element is an element in the fields list. So from the fields list, I take the index of the element in question. And from that, I take the length. Okay. I then have a list comprehension that does that. And then I take the maximum of that list comprehension, and that gives me the same numbers. Now, just to remind you what the table looks like, let me make that a little bit bigger. Okay. So we will have a column header. We will have a divider line here, a divider line there, and then we will have our information. Because we calculated the column width to be the maximum required width, you can see that all the words fit within the column and that you can have some space or some padding around that, and everything is nicely centered as well. Okay, so how do we do that? First thing to calculate is our divider row, which is this line of dashes here. So again, I use a list comprehension. I'm going to look for every element in max lengths. Okay, so I'm going to create a list. Max length, remember, holds the column width for every column. So for every column in there, I'm going to use a dash times x plus 3. So I can take the maximum length, I add 3 to that, and that's the number of dashes I want to draw, okay, for each particular column. Now, of course, I want one single line, so I then want to join these together, but I'm not going to put anything in between. I'm just going to put an empty space, not even a blank, just nothing in between. So I'm using nothing. I join all these dashes together, which will then give me a line that is of the right length. Okay. Now, the second thing to do is to create this header row here. So it's possible to construct list comprehensions for two variables, but we've touched on nested list comprehensions in the previous video, so I'm not going to go through that again. I want to show you something different, which is a map function and a lambda function. So I'll be using a map function to map a lambda function that does the centering. The centering, what do I mean the centering? I want this to be centered. Okay, I want the column headers and I want those names to be centered in the column. So that will give me a map object. Okay, I then use the list function to turn that map object into a list, and then I will convert that list to a string using the join function. Okay. Now the other things that I'll be doing is I'll be using title on a string to make sure that everything starts with a capital, and then I will be using the center function to center the word in the column, so based on the column width given. Of course, to center something, it will need padding, and the default padding is space. So you can see SSID, for example, there's spaces here and spaces there, and it's nicely centered in the middle. So how do we do that? For header row, for example, the header row, which is this one, let's start with the lambda function. So the lambda function uses two variables, x and y. X will be a string, y will be the length. How do I know that? The map function will map the lambda function onto these two iterables, fields and max length. Fields is the list that holds the column names, and max length is the list that holds the maximum width or the required width for each column. So I'll create a lambda function using x and y. From x, which is my string because it comes from fields, I'm going to apply the title function, which capitalizes the first character, and then I'm going to slice it to take the whole thing except for the last character, because the fields list holds the column names, but it holds the column names with the equal sign at the end. So if I scroll all the way to the top, remember this is my fields list, it has equal, equal, equal. Of course I don't want that in my title. So I apply the title function and take off the equal sign. The next thing to do is then to make sure that the text is centered in the column. So I need to center it over a certain width, and the width I'm going to be using is the max length, so the column width, but I'm going to add one just to have a little bit of space. So that lambda function is mapped to those two iterables. Okay, that gives me a map object. I want to convert that into a list. So I apply the list function, and once it's a list, I can convert it all into one big string by using string.join. Now, what do I want to use to join them? Well, I want to use this pipe symbol here. So we've got a nice little line. Okay, so that is what this does. So this gives me the header row. So I'm going to print the divider row, the header row, and the divider row. So divider row, header row, divider row. So what's left to do is then print all this. To do that, we'll use the exact same logic, of course, but now we are not looking at the fields list, which holds column names. We're looking at the output list, which holds the metadata of each of my network files. So for each element in there, what I'm going to do, I'm going to check firstly that the first element is true, so there's something in there, just to make sure that we exclude everything that has no value in it. And then the network line we'll be creating is very, very similar. So there's a lambda function, x and y. I'm applying the same Boolean trick here, but actually I don't need to do that because we've already established that this is not going to be a problem. The x comes from L, from the element, and we're in this if leg that says if EL0 is truthy. So if it's true, then this AND is not going to make a difference. But I left it in there just to show you that in a Lambda function, you can use the Boolean trick to avoid crashes or errors, if you like. So I'm going to center X as we did before, and that will center the words here in their columns. And then I'm going to print this network line. The last thing to do is then to trigger the program, if you like, to start the app. So to run our app, we just need to knit together all the pieces we've built so far. And the first step for that is to create a list comprehension that creates my output, which will be the files to go in here. And the way to do that is, well, we build a list comprehension that uses the build commands function to build up all the commands that we need to run. And for each of those commands, we're going to then extract the network meta fields as we just discussed. And then I'm going to finally apply the output to terminal function to that to actually create the table. So that is how in Linux you can extract your Wi-Fi passwords in case you've forgotten them. I hope you found this helpful and useful. If you did, please like the video or even consider subscribing to the channel. Thank you very much. See you soon. Bye.